Alright, you're welcome to my YouTube channel. This is the boiling point. Remember to share, subscribe, and hit the notification bell. The Sky Academy, that is the YouTube name, the Sky Academy. So we've been talking about motions, and by the grace of God, I'm done with all the linear motions, both the vertical linear motions, the horizontal linear motions. Please, if you've not watched my videos on those aspects of motions, please do that. Go and watch it. I solve all the past questions regarding to anything called vertical and horizontal linear motions. So today I will be dealing with what we call the circular motions. That is motions that move in a circular path. So a body that is moving in a circular path, suspended at an angle theta, and has what we call a radius. So the first question that I'm having on the body here is that a mass 5 kg moves around a circle of radius 5 meters with a constant speed of 15 meters per second. Its angular velocity is dash. Option A, 3 rad per second. Option B, 20 rad per second. Option C, 2.5 rad per second. Option D, 75 rad per second. So how do you solve this? If you're solving an equation in physics, there's what we call data. Data will help you to be able to know what formula you will apply in order to get the answer. Now, if you watch this first question, they gave us a mass of 5 kg. So the mass that was given to us is 5 kg. So this mass of a body moves around a circle of radius 5 meters. They gave us radius 5 meters. So they gave us mass 5 kg, radius 5 meters with a constant speed. That means they gave us speed. What is the speed? 15 meters per second. 15 meters per second. Its angular velocity is dash. That means we are looking for angular velocity. What is angular velocity? Angular velocity is omega. So if it is not called angular velocity, it's called angular frequency. So depending on the nature of what you're being asked. So how do we solve this? Now, for me to solve this, I think the mass will be useless for me. Why? Because there's a relationship between angular velocity and linear velocity. So this omega is angular velocity. Why? This v you're seeing here is linear velocity, and the relationship between angular velocity and linear velocity is that linear velocity is omega r. Linear velocity is omega r. So if linear velocity is omega r, what do? You make omega the subject of the word formula. That means divide by r, divide by r. This r will cancel this r. That means omega is equals to velocity over r. Did they give us velocity there? Yes. What is the velocity? 15. Did they give us the radius? Yes. What is the radius? 5. 15 divided by 5, you have that omega is 3 rad per second. That is the SI units of omega. So the best answer there is option A, which is 3 rad per second. Now, going to question number 2. Going to question number 2, remember, I told you don't joke with data. He said the relationship between linear and angular acceleration is dash. Option A, angular acceleration is equal to linear acceleration. Option B, linear acceleration is equal to radius times angular velocity. Option C, angular or linear acceleration is equal to radius times angular acceleration. Option D, angular acceleration is greater than linear acceleration. So there is a relationship between linear and angular based on acceleration, based on velocity, based on displacement. We have linear displacement, we also have angular displacement, and there is a relationship between all of them. The relationship between linear displacement and angular displacement. Linear displacement is equal to theta r. So some will not use it as L, some will use it as S. It's still the same thing. Linear displacement is equal to angular displacement times R. Linear velocity is equals to angular velocity times R. This is the relationships. The linear acceleration is equals to angular acceleration times R. So angular acceleration, anything angle times it by R is equal to the linear. So this is the relationship between all of them. So for the question they asked us, what is the relationship between linear acceleration and angular acceleration? This linear acceleration is equal to angular acceleration times R. Do we have anything like that in the option? Yes, which is option what? C. So question number 3. Question number three, they said a body moving at 4 meters per second in a circular path of radius 5 has a period of dash. Remember, for you to solve any question under physics, the first thing you will do is to bring out your data. Your data helps you to know what formula you should apply for you to be able to solve the question. So data, that is the first thing. They said a body moving at 4 meters per second. So that means they gave us velocity here. What is the velocity? 4 meters per second in a circular path of radius. So they gave us radius. Radius is equal to 5 meters. They gave us radius, which is equal to 5 meters. Has a period. That means we are looking for period. We are looking for period. Period is T. T. So, what formula can you relate with this? What formula can you relate with this? What formula can you relate with this? Okay. Can you recall? Can you remember that I have omega? Omega is equals to 2 pi over T. Can you remember? Omega is equals to 2 pi over T. And linear velocity is equals to omega R. So let me call this one the equation 1. If we make omega the subject of the formula, I can have it that omega is equal to velocity over R. Call this one equation 2. So in equation 1, if omega is equal to 2 pi over T, and equation 2, omega is equal to V over R. Do you know the reason why I'm doing this? I'm doing it because they gave us velocity, they gave us radius, and they gave us time. So I can equate these two equations together. So it means that velocity over R is equal to 2 pi over T. And if you're looking for T, just make T the subject of the what formula. That means you have that T will now be equal to 2 pi R over V. So I'll have it as 2 pi. Now, why am I writing pi? You discover that all the answers are in pi's. So radius, what is the radius? 5 over, what is the velocity? 4. So the velocity is 4. So what am I going to have? I will have it as 2 times 5 is 10. 2 times 5 is 10. That means T is equal to 2 times 5 here is 10 pi all over 4. So what is 10 pi over 4? Let's check it. 10 divided by 4. 10 divided by 4 will give me 2.5. Wow. I have it that T is equals to 2.5 pi then per seconds. Per seconds. So per hence, anyone, I'll have it as 2.5 rad per seconds. Rad per seconds. So do I have anything like that in the option? Yes, which is option what? D. So the correct answer is option D. So the fourth question that we will be having, here the fourth question. They said if an object of mass 5 kg moves around a circle of radius 5 meter with a constant speed of 10 meter per second, its centripetal force is dash. So you need to analyze the question. So you discover that we are looking for centripetal force. Remember, the first thing is to bring out your data. So what is your data? If an object of mass 5 kg, so mass here is 5 kg. That is the mass here. Moves around a circle of radius 5m. So I have radius of 5 meter. I have radius of 5 meter with a constant speed of 10 meter per second. So they gave us speed which is 10 meter per second. Its centripetal force, we are looking for what we call centripetal force. The centripetal force is unknown. What is centripetal force? Centripetal force is a force that keeps an object in a circular path. It is directed towards the center. Note it. They can ask you, are you getting what is the direction of centripetal force? It is directed towards the word center. They can also ask you what also provides the centripetal force. What provides the centripetal force is not gravity. It is not acceleration. It is the tension. Are you getting? The tension can come from the rope. It can come from anything that is actually keeping the object in that circular path. So that is actually what provides the centripetal force. Now this centripetal force, the formula for centripetal force is that centripetal force, which is Fc, is equals to mv square over r. mv square over r. That is the formula for calculating centripetal force. I now have that Fc, what is the mass? The mass is 5 times, did they give us velocity? Yes, which is 10 square, all over, did they give us radius? Yes, which is 5. Therefore, this 5 we cancel this 5. What is 10 square? 10 square is 100. So that means the centripetal force here is 100 Newton. So do we have anything like that in the option? Option A is 100 Newton. Wow. Option B is 250 Newton. Option C is 50 Newton. Option D is 20 Newton. So the correct answer here is option A, which is 100 Newton. Then question number 5. Question number 5. I have a mass of 0.5 gram moves in a circle of radius 1m. So we have a mass data. What is the mass here? 0.5 kg. That is the mass. Moves in a circle of radius 1m. So what is the radius? Radius here is 1 meter. With an angular velocity, they gave us angular velocity. Angular velocity, which is omega, is 4 rad per second. Find the centripetal force. They are still asking us to calculate the centripetal force. So in this case now, what do? They gave you mass, they gave you r, which is radius, and gave you omega, which is angular velocity. But they didn't give us linear velocity. Okay, what you will do is this. Can you recall that centripetal force is equals to mv square over r? Can you remember this formula? Yes. This is actually formula that you use when mass is given to you, linear velocity is given to you, and radius. But in this case, they didn't give us linear velocity, they gave us angular velocity. You can recall that v is equals to omega r. Can you recall that? That means any place I see v, what am I going to put? Omega r. I'll have centripetal force equals to mass. Then what is v? V is omega r, everything all square all over r. Can you remember this? Or let's simplify the formula. You have it as m, then omega square r square all over r. One r will cancel one r here. What will be centripetal force? Centripetal force will now be m omega square r. So this is actually a formula for calculating the centripetal force when angular velocity is given to us. So I will now have the centripetal force, which is Fc, will now be, what is the mass here? 0.5. I have the mass at 0.5 times, what is omega? Omega is 4, but omega is squared, which is 4 squared times 1. I'll have it as times 1, which is 0.5 is 1/2. Then this is 16, if I'm not mistaken. Okay, 1 divided by 2, yes, is 0.5. So this is 1/2 times, what is 4 squared is 16 times 1. So 2 here is 1, 2 here is what? 8. So I will now have the centripetal force here is 8 Newton. So do we have anything like 8 Newton in the option? Yes. Option A is 7 Newton, option B is 5 Newton, option C is 4 Newton, and option D is 8 Newton. So in this kind of question, what do? You get angry and you leave the hall. Then we'll continue with question number 6. Thank you.